This video is going to serve as an introduction to ANSYS and using ANSYS FLUENT, specifically with the Workbench 17.2. And I'm using this for my desktop in Bancroft, so the process will be possibly a little bit different if you're connecting from Rickover. But you're going to start by pulling up the remote desktop connection. You just search from your programs on your computer, and you're going to get set up with the computer guys downstairs in Rickover, so you can use the remote desktop. So just going to sign in, and this is the desktop for the Kitty Hawk computer. And so you just go into Programs and search Workbench. It'll be pre-installed, and it's going to pull up this big array of programs that uses a whole lot of different fluid dynamics and CAD, but all we're going to be worried about is the FLUENT aspect for aerodynamic applications. So this is the main interface. All you're going to do to start a project is click and drag the FLUENT to a standalone system for now. And what's going to pop up is the project manager, and this part's pretty simple. There are 5 steps that you follow, starting with geometry to complete a project, and in the example, we'll go over each step individually. So before I jump into the example, which is going to be a laminar pipe flow solution, just a few things that we should talk about, that you should be aware of with CFD, and that is you should do some reading beforehand to figure out what CFD is actually doing if that's not covered entirely in his class. And before you start producing an analytic solution for CFD, you should do some hand calculations like this. So for a laminar pipe flow solution, you get something familiar to what you'd see in gas dynamics, or I guess in aerodynamics. And this actual example I'm going to be following is from Cornell's website, and they have a ton of good examples how to use FLUENT. So it's definitely worth looking at the website if you want to get more into it. But before you jump in and you spend a lot of time creating a model and a solution, you should have a roundabout answer on paper. Otherwise, you junk in, junk out. If you mess up the process, answers are way off, and you really won't know the difference. And then once you have a model that works, then you can begin to change environmentals, change the model to whatever you want to do that requires numerical integration and the other things that the FLUENT's good for. So with that, we're going to start with the example in the next video of the pipe flow.